Hello all, welcome back. Today we will have a look at a sample MapReduce program written in Java which will be run in our Hortonworks sandbox virtual machine. The prerequisites required for today are the Hortonworks sandbox which is run in our virtual machine, JDK 7, a Java IDE like Eclipse, something like WinSCP for jar file transfer into the VM, an SSH client like PuTTY or SSH Textia. This example is taken from github.com, the URL for which is given in the document. The MapReduce problem is for computing the election result of an imaginary country called Utopia. So there are 5 contestants for the elections like Jaja, Gigi, Jojo, Juju and Jinjin. Pretty funny names, I should say. After the voting, each polling booth will have an output of a text file, and within each text file of each booth, every vote cast for a candidate will be represented by one line. For example, if the first vote of the polling booth 3 goes to Jaja, the first line would look like Jaja, and if the second vote goes to Jojo, the second line will have Jojo, and so on. So here is a text file example for booth number 1. You can see all the candidate names here, which represents each vote by a different person. So the first step will be to download the Hadoop library from the Apache site. So if you click this link, you will reach this site where you can download the Hadoop. You can see different versions here. The library which we download for Hadoop should match the version of Hadoop which we have in our virtual machine. So for HTTP 2.3 Hortonworks, you can see the Hadoop version is 2.7. So we should be downloading 2.7. So this particular file, the tar.gz, should be downloaded. Once the download is complete, just unzip the tarball.gz file using winrar or winzip into a folder like this, and just ensure that your folder has these 3 files which are listed in the document.
The next step is to create the MapReduce project in Eclipse. So I bring up my Eclipse IDE and create a new Java project. The name of our project will be Utopia Vote Count as per what we have given in the document. And I'm using a JRE environment 1.7 version. Hit finish. You can see that the project is created. Since we are going to use Hadoop MapReduce functions in our project, we need to make sure that we add the corresponding libraries to our project. So I go to the project, right click, go to properties, Java build path, on libraries tab, select add external jars, go to that folder where we had downloaded the jar files. So these are the locations of the jar files. Hadoop MapReduce client core and job client. Apply and select OK. The next step is coding the mapper class. So I go to a project, right click, new class. I give a package name Utopia MR for MapReduce, and then my mapper class will be named as vote count mapper. So the new class is created, and coding wise we can just use the same code as it is in the document. Just a quick overview on what the code does. The vote count mapper extends the class mapper which is defined in the Hadoop library, and it takes an object and a text as an input and gives an output of a text and an int writable. So this line here, it is just assigning the value of variable 1 as int writable 1, and it uses a predefined function map to take a text value, and it splits the text into a string array if at all there is a space in between. So basically, if there are like two words in one line, it's just ensuring that it's actually split into an array. In our case, it will not be used because all our candidates are like one-liner words with one word in each line. And the output of the mapper function is like to pass the text and the first word in that array. Basically, they're just using the first name and passing the number 1. Just giving an overview of how the process works. So if this is an input file, the input split takes care of splitting the words in each line and feeding it into the map function. So map function takes one word at a time and gives an output of the word and number 1. Let's code the reducer class now. Same procedure, right click, new class. I'll just use the name vote count reducer under the same package. Finish. So the new class is created. Just use the same code, replace it. Let us see now what the reduce function does. Our map function gives out an output of the candidate name and number 1 for each of the map output and passes it on to the sort shuffle logic. The sort shuffle is built within the Hadoop libraries. So what it does is like it collects all the key value pairs for the same key and groups them together. So in our example here, you might have like multiple outputs of Jaja, 1 from different map functions for different lines of the input files which came in. The sort shuffle just groups them together and collects all Jajas and the one key value pairs together and passes on to the reduce function. And the same goes with the other key values like GG and so on. So if we have a look at the reduce function, the name is vote count reducer, which extends the reducer class. The input is a text file and an int writable, which is actually sequential, and output is a text and an int writable. It overrides the reduce function, takes the text as an input, which is our candidate name in each case, and takes an iterable int writable, which is like sequentially it takes number 1 each time for an each input, and then it initializes vote count of 0 to start with for each candidate, and then for each key value it increments the vote count by the value, which is usually 1 in our case, and finally after the counting is done, it gives an output of key, which is the text, and int writable of vote count, which is a total count for each candidate which it has read. And finally, let us now create a MapReduce application or driver class, which will be the main class. Repeating the same procedure, new class. Let's give the name as vote count application because that's where the flow will be driven from. Finish. The new class is created. Let's copy the code, which I'll be explaining in a short while. Now let's have a quick look at the main application named as vote count application. So when we run the vote count application, we are expecting a string argument, and the first part of the argument array should be the input path. In other words, the location of the input files, basically the text files from the polling booth output, and argument 2 will be the output path where you want the final vote count to be. The function also sets a job characteristics, expecting the job output key to be a text, which is the name of the candidate, and output value to be an int writable, which is the total vote count. It also defines and sets the mapper class as vote counter mapper, which we had already defined, and reducer as vote count reducer. And finally, it submits a job. The Hortonworks HTTP in your system still uses Java version 1.7. So we should be matching the Java version in our compiler as well. So let's go back to the project, right click, properties, go to Java compiler. As you can see, like it's 1.8, which is the default version installed in my machine. I'll change that to 1.7. Apply. Rebuild the project. The next step is to create a runnable Java archive jar file. Go back to the project, right click, export, select jar file. Next, select only the project which we need. Cross-check the path where the jar file is created. So it's like under the bin folder of the main project folder which we had created. Finish. Now if we go back to the location where we had saved the project, so workspace, Utopia word count, bin, you can see like the jar file has been created. At this point of time, we should have the Hortonworks sandbox up and running with this screen. Just make a note of the IP address right here. Now our next step is to copy the jar file which we had created into the Hortonworks sandbox. For that, we need to use an FTP tool like WinSCP is what I'm going to use. I've just brought WinSCP up. So the hostname will be what we see on the sandbox, 198.168.150.128. Please note that this will differ from system to system. If you set the sandbox in your laptop, it might have a different IP address. Whatever you should be using here should match what is shown in the sandbox's home screen. Port number 22 is default, and the username is root, and the password is Hadoop for everybody. I have brought the WinSCP up. So WinSCP copies a file into a Unispace system based on FTP protocol. On the left side, you can see my source file system, which is actually Windows NTFS. I go to the workspace folder, which we had defined earlier. Go to Utopia word count, which is the project, bin, and here is our source file, Utopia jar. Check the modified time to make sure that you are taking the right jar file. On the right hand side, we are supposed to copy the file into root/usr/lib/hue location in order to run the MapReduce program. I'm in root user lib hue. So I just drag and drop this file and it's getting copied. As you can see, the file has been copied fine. The next step is to create the input data for our MapReduce program using the Hue web interface. So we used the same IP address and port number 8000, which will give you an interactive UI based in Hue. And this icon right here is a file browser, which will give us the list of files which are under the HDFS system. And using this Hue file browser, we will be uploading the input data files. I have created some input data files in this folder in my Windows laptop, and I'll just open one of the files to just show the content. So these input files are .txt files in format, and they represent the output from each booth. So booth 1 gives like output of the votes cast in booth 1, and each line is a vote for that corresponding candidate. To create the input file, first of all we need to create a new directory, and I name it as vote count input as per the document, and make sure that we are under /user/hue. So we are under /user/hue, and there's a new input directory, vote count input. I go inside vote count input and upload the files. So these are the three files, booth 1, 2 and 3. So all three files have been uploaded successfully. Just clicking one of them to ensure that we have the right input. Now we are all set to trigger our MapReduce job. We have created a jar file. We have copied the jar file into the Hadoop system. We have also created the input files. To trigger the MapReduce job, we'll be using putty. I'm just triggering up my putty.exe. Use the same IP address as in your sandbox. Port number 22. It asks for like login credentials, and our login credentials will be root and Hadoop. To run the MapReduce job, we'll need to be logged in as the Hue user. To switch user, I use the command su space hyphen space Hue. Now I'm logged in as the user Hue and not as root, which can be confirmed with the command who am I. Now let's go to the location where we had copied our jar file, cd/usr/lib/hue, where we had used the WinSCP to copy the jar file. Just return ls to list and make sure that we actually have our Utopia MR file listed, and here is our file. So if we see here, yarn is the command to fire up the MapReduce job, jar is the type of the file, and this is our application, which is a jar file. And if you remember, during your program coding, we had given two arguments as parameters for the job. The first one was the input location, where we need to pick up the input files, and the output we are expecting is to be in /user/hue/word output. And this is a location where we had copied the input files just a while ago. Now we are all set to run the MapReduce job. As you can see here, at any point in time, just make sure that your output folder is not created in your user/hue location, because if the output folder is already existing, your MapReduce job will fail. So I'm just going to run the job now. As a next step, let's see how the MapReduce job is executing, which is basically monitoring the MapReduce job. Let's go back to the Hue UI and select this browser, which is job browser. So my job browser currently shows one job, which is in accepted status by the user Hue, which we had triggered using putty.
And finally, our MapReduce job Utopia MR has completed, as the status says succeeded. It took me like around 16-17 minutes for completion. Your case might vary based on the input file size and your machine configuration. So we'll go back to the file browser, which takes us to user Hue. And if you see here, it has created a folder called as vote count output, which was not there earlier. I click that, and there's a file called part r000. On clicking the part r file, we can see the final output of the MapReduce program, which shows the total vote count for each of the candidates. And with this, we can easily see like Jojo, with the maximum number of votes 16, has won the election. And that's about it. At this point of time, we have successfully completed a MapReduce program in Hadoop. Thank you.